Okay, so the next topic is applications of authentication. So the first one, what we are going to study is Kerberos, students. Let me give you an idea about what is Kerberos. Kerberos is an authentication service. Okay, so basically, how authentication services has to be provided. So Kerberos is an application. The Kerberos authentication model implemented. It is implemented using Needham-Schroeder authentication protocol, which you already know. I have explained what is Needham-Schroeder authentication protocol. So basically this protocol is against eavesdropping, and it relies on, if please, some of the points which is not there in slides, you have to make a note of it, students. Kerberos is an authentication service, okay, and it is based on Needham-Schroeder authentication protocol, and it is secure against eavesdropping, and basically relies on a secret key symmetric encryption scheme. Is that clear? A secret key symmetric encryption scheme. So what are the requirements? See, the typical Kerberos environment will have a Kerberos server. You can please make a note of it. The typical Kerberos environment will have a Kerberos server, number of clients, and number of application servers, which has to satisfy the following requirements. Okay, I'll tell you those requirements. I'll repeat it again. The Kerberos environment consisting of Kerberos servers, number of clients, and a number of application servers has to satisfy some of the requirements. What are those requirements? First one is security, second one reliability, third one transparency and scalability. Security, reliability, transparency and scalability. Is that clear? So this is the Kerberos authentication. Now we will see how exactly the Kerberos authentication works. So based on the slides what we have, you can see here there are two versions of Kerberos, that is 4.0 and 5.0. I will briefly tell you the difference of these versions later. So users at workstations wish to access services on servers distributed throughout the network. Servers should restrict access to like authorized users, and to authenticate requests for the services. Say for example, there are servers, say Google server, say a Gmail server. You want to authenticate yourself to the Gmail server. How it will be done? The same. A workstation cannot be trusted to identify its users correctly to network services. Three threats will occur. Okay, user will gain access to the workstation and pretend to be another user operating from that workstation, or user may alter the network address of a workstation, or user may eavesdrop on exchanges, and a replay attack used to gain access to the server or to disrupt the operations. Okay, these are the three attacks. So for a workstation, basically a workstation cannot trust to identify its users. Okay, so instead of building authentication protocol at each server, so it's a centralized authentication mechanism, students. Kerberos is a centralized authentication mechanism. Okay, so instead of building an authentication protocol at each server, Kerberos provides a centralized authentication server, relies exclusively on symmetric encryption. Is that clear? So this point you have to clearly understand. Kerberos is a centralized authentication server. Say for example, you have multiple workstations, and instead of building an authentication protocol in each and every server, so that clients can access it, you have to have a centralized authentication server and go ahead with that. Let us see how it works. So three approaches to security is predicted. So what are those three approaches? Let us see. To rely on each client to assure the identity of its user, or to rely on each server to enforce a security policy based on user ID. Okay, requires that clients should authenticate themselves to the server, but to trust the client system, concerning the identity of its user. Require the user to provide identity for each service invoked. Also require that the server prove their identity to client. So Kerberos basically is with respect to the third approach. You can use any approach, but Kerberos is working with the third approach. Require the user to prove identity for each service invoked. That means you are a user, you are asking something from the server, you have to prove your identity. Also require that servers prove their identity to clients. I also, my requirement is server, I should know whether I am reaching the right server or not. Okay, that information also I should have. So basically it is two-way authentication. Both client and server will authenticate themselves for communication. So who is supporting it? A centralized server is supporting it. How it will support, we will see to that. Okay, so Kerberos is distributed client server architecture. Employs one or more Kerberos servers to provide an authentication service. As I said you before, requirements are security, reliability, transparency, and scalability. What is security? A network eavesdropper should not be able to obtain necessary information to impersonate a user. That means impersonate means instead of me, somebody is giving me, instead of server, somebody is giving me information. The other way also is possible. So it should be reliable, should employ a distributed server architecture with one system able to back up another. Okay. Then it should be transparent. That means ideally user should not aware of authentication. I mean, user is not worried how things are going on behind. Okay. User should just give a password, but in the backend things should work properly. So scalable, should be capable of supporting large number of clients and servers. So if you have large number of clients and servers, a Kerberos server should support all the clients and servers, service servers. Okay. So that's about the architecture. So let us go with this. Let me take a pointer. This is a very important slide, students. You have to understand here. Okay. So you can see there are four components. They are clients, or you can call them as users. Then you have authentication servers, that is basically Kerberos authentication servers, and ticket granting servers. Is that clear? So one thing I have to make sure for you students, a Kerberos server is combination of these two. Okay, this is Kerberos. This is Kerberos, students. Combination of these two is servers. Kerberos server. See, it might be some server you want to get some data from this service server, a user. Okay. So now user cannot directly contact service server. Is that clear? To contact the service server, user should get a ticket from here, from the Kerberos system. So what tickets are required? Let us see that. First, user will send a request to the authentication server requesting for a TGS. TGT. Is that clear? Sorry, TGT. So what do you mean by TGT? Please make a note of it. It is ticket granting ticket. Is that clear? It is in short, it is called as TGT. It is called as ticket granting ticket. The user send a request to the authentication server. User sends a request to the authentication server. In return to that, authentication server will give a ticket granting ticket. Okay. So what is this? So there will be totally 8 messages that are exchanged here, students. So what is message 1? This is message 1. Okay, you can make a note of it. So the client sends uh, sorry, so client sends a request for ticket granting ticket, so using encrypted using a session key. Is that clear? So all the connections, all the communication between users and authentication servers will be encrypted using a secret key, sorry, using a secret key. Is that clear? Of C, Secret key of C means C is user here. I will call it as C. Okay. C means user here. So in message one, basically what happens, a session key. Okay, let me write it here. C hyphen T G S. Okay. I will share you another diagram also. You can, okay. Um just give me a second. I will add this diagram. Okay. That will be more easy for me to understand and for you also to understand clearly. Let me erase it. I will add a diagram, students. Just give me a minute. Okay. Is it visible to you, students? Is the diagram clear, at least to some extent? Yes or
Yes.
no? Okay. Okay. See, this is the Kerberos authentication server. You can see a Kerberos server in between client and actual server. Okay. Client want to send a request to actual server to get some services, but before that, authentication has to happen through Kerberos. Is that clear? So first, what happens? Uh, First, user login. Okay, user logs on to the workstation by entering username and password. So that's it, we are not worried about it. Then from second step, you will see the actual Kerberos system. So the request goes from client to the authentication server. Message one. This is message one actually. Okay, this is message one. So C means client, TGS means this server. So a session key of C and TGS encrypted using secret key of C. Is that clear? In message one, what you have C TGS session key encrypted using the secret key of C. Is that clear? Secret key means private key of C. So for that, M2, when it is encrypted using the private key of C, easily this Kerberos system authentication server can decrypt it using the public key of C. Is that clear? When it decrypts it using the public key of C, what it will get? It will get a session key, that is C TGS session key. So what it will do in M2? This is M2. M2 is this one. Okay. So TGT, ticket granting ticket. It is sending a ticket granting ticket encrypted using the secret key of TGS. Is that clear? Encrypted using the secret key of TGS. So secret key of TGS, again client can know it. It is public key, it can know. So it will decrypt the TGT, that is ticket granting ticket. Is that clear, students? So let me read out again. In message one, it contains the client TGS session key encrypted using the secret key of client or user. Is that clear? In message 2, what happens? It have the TGT, ticket granting ticket, that includes not just that one. Please note that this includes the client ID, client network address, ticket validity period. I mean, the ticket will have all these things. It contains a ticket granting ticket that includes what will be there in the ticket. It will have an ID, network address, ticket validity period, and client TGS session key also. Is that clear? That this whole things will be encrypted using the secret key of TGS. Is that clear? What happens after getting TGT? What will happen? So authentic, this first step is called as authentication with authentication server to obtain TGT. Next thing is authentication with ticket granting server. TGS means ticket granting server to obtain SGT. Is that clear? What you received from authentication server is ticket granting ticket. What you are supposed to receive now is SGT, that is service granting ticket from ticket granting server. Is that clear? From here, by the diagram, you should understand that. So the next thing is message 3. This is message 3. Message 3 is sent from whom? From client to TGS. To reach TGS, you need to have a ticket granting ticket, which you already have. Okay. So what will be there in message 3? Message 2 as it is. Is that clear? A ticket granting ticket encrypted using the secret key of ticket granting server, that will be there, and ID of the service. Is that clear? There will be a ID generated for the service, that also will be there in the message 3. M2 as it is and ID of the service. Then for that, TGS will have to respond. So message 3 will have message 2 as it is and ID of the requested service. For that, TGS, upon receiving this, what it will understand? Okay, it's a ticket granting ticket, and it looks into the ticket and it will find, okay, in the ticket there is the client ID, and it also have client and TGS session key for next communication between TGS and client. So these things are available, hence it is from the right way. So let me give something what it is requesting for. So what it is requesting for? It is requesting for SGT, service granting ticket. So for that, as a response, this is the fourth message. You can see message 4 is from ticket granting server to the client. Authenticator, what it will send? It will send an authentic. Okay, just a second, student. Yeah, in message 4, it sends an authenticator encrypted using the CTGS session key. Is that clear? An authenticator using the CTGS session key. How this TGS got the session key? It is through client itself. It has sent the session key also. Is that clear? So M4 is basically yeah, let me read it again. M4, this is an authenticator that includes client ID and timestamp encrypted using the client or TGS session key. An authenticator is required to provide replay of old requests to the same server and replay of requests on the server to another. Is that clear? So basically, I wanted to tell you, this is wrong. Let me remove it. This I will remove because okay, now see, a small confusion, students. Let me clear everything. Okay, so students, as per the diagram, and I did a small mistake while explaining. First, authentication will happen between client and authentication server. For that, the client will just send a request. Is that clear? And that request is TGT request. Is that clear? It sends a request that is just TGT request. So the client sends the user ID to authentication server. If the client is in the authentication server database, then it sends the following messages. Is that clear? So client sends a TGT request to the authentication server, and if authentication server finds this client in its database, because client has already logged into the workstation, it will be there in the database. So once it is there in the database, authentication server will send two messages. This both M1 and M2 is message sent from authentication server to the client. Sorry for the confusion which I made. This M1 and M2 is sent by authentication server to the client. What will be there in M1? Session key encrypted using the secret key of C, because the secret key is not the private key, as I said you before. Secret key is a key exchanged between client and authentication server. So this a session key, that is CTGS, which is used for further communication with TGS, is generated by this authentication server, and that encrypted using the secret key of C will be sent to the client. Is that clear? And then upon that, uh, with that, it will also send a message that is ticket granting ticket encrypted using the secret key of TGS. Is that clear? So what secret key here means, when authentication server encrypts a session key, that is CTGS. Is that clear? It encrypts CTGS using the public key of the client. What happens? Only client can decrypt it. Is that clear? Using the public key of client, only this client can decrypt it. And if you see at message 2, there is a TGT, ticket granting ticket, that is encrypted using the secret key of TGS. That means it uses the public key of TGS to encrypt it. See, so only this TGS can decrypt this M2. Is that clear? So as simple as that. Now, upon receiving these two messages, this client has to send a request to TGS, sorry, TGS, ticket granting server. Requesting what? Requesting service granting ticket, because you need service granting ticket to reach the actual server. Is that clear? Now, two messages will be sent from client to this TGS. What are those two messages? M3 and M4. In M3, what you are adding? M2 as it is, because it's a ticket granting ticket encrypted using the secret key of TGS. Only TGS can decrypt it. So M2 is sent as it is with ID of service, and also one more message, an authenticator encrypted using the CTGS session key. This CTGS session key is sent to this client by authentication server. So it encrypts authenticator encrypted using CTGS session key. Is that clear? Now, I guess first this step 2 and step 3 is clear to you. Any questions do you have regarding these two, students? Shall we go ahead? Am I audible?
Yes.
Okay. So hope it is clear to you. So first, client will send a request to authentication server requesting for a ticket granting ticket. For that, authentication server will send two messages. One, a session key for communicating with TGS, which is encrypted using the secret key of C. One more, a ticket for reaching TGS, that is encrypted using the secret key of TGS. Is that clear? So for that, this client will send two more messages to ticket granting server, because it has ticket granting ticket now. One message to, that is ticket granting ticket, that itself, and then one more message, that is M4, an authenticator encrypted using the session key generated by authentication server. For that, this ticket granting server will send two messages, M5 and M6. Is that, let us see in M5 what it is there. Because client is requesting for a ticket grant, service granting ticket, it sends that service granting ticket encrypted using the secret key of V. V is this one, students. V is this server. Is that clear? So as authentication server sends the ticket granting ticket encrypted using the secret key of TGS, similarly TGS has sent a ticket, that is service granting ticket encrypted using the secret key of server. Is that clear? So service granting ticket encrypted using the secret key of V, that is server. So next, in the next communication, client should send this M5 as it is to server. Let us see that. With that, this TGS sends one more message, that is client and V session key. It has created a new session key for communication between client and server. V is server. Is that clear? A session key generated by TGS for communication between client and server, encrypted using the CTGS session key, which is already generated, and it is generated by AS, and both client and TGS have it. Is that clear? So M5 and M6 will be communicated from TGS to client. Is that clear? Now client has the ticket to reach the actual server, that is service granting ticket, which will be sent as it is by the client. You can see here authentication with V, that is actual server, to obtain service. What it is sending? It is sending M5. What is there in M5? A service granting ticket encrypted using the secret key of E. That means only server can decrypt it. So M5 it is sending as it is. With that, it is sending another message, that is M7, that is authenticator encrypted using the CV session key. Who has generated the CV session key? This TGS has generated the CV session key in M6. You can see M6 CV session key encrypted using CTGS session key, that is given to the client. So using that session key, it communicated with actual server, sending the authenticator. Exactly. And now server is confirmed that it is a genuine connection request, because already Kerberos has authenticated it by giving it a ticket, that is service granting ticket. So M8 is a message coming from server to client. So it will have timestamp found in the authenticator. Basically, what will be there in the authenticator? A timestamp. Is that clear? So timestamp plus one. It is adding one number. It's just a number. So it is sending it back, encrypted using CV session key. Now authentication between server and client is also done. So all the authentications are completed. So finally, the fifth point is servicing. That means client issues service requests to we will send responses. Is that clear? This is a authentication mechanism. So with the help of Kerberos authentication server. Is it clear, students? Is it clear to you? Do you have any questions regarding this? Hello? Am I
No,
audible?
sir. Yes, sir. Yes.
Okay, so I hope this Kerberos authentication servers are clear to you. So in the next class, I will explain you about what is V4, version 4 and version 5 authentication, Kerberos authentication servers. So that's a small topic. Then we will go to directory services. Okay. So this diagram is very
Sir,
important, students. Yeah.
sir, message 5,
Yeah.
that is TGS is encrypting using, how can TGS encrypt using secret key of server, sir? It can
Secret key,
encrypt.
the sense secret key is a pair, that is public and private key pair. So when this M5 is encrypted using, that is SGT, that is service granting ticket, is encrypted using the public key of this server, who can decrypt it?
Only server can.
Only server can decrypt it. That's why it is called as secret key. That's all. Don't get confused with that. It is, you can consider it as a public key of the server. Is that clear? Nobody else can decrypt it, right? When you encrypt it someone with someone's public key, only the key pair, the private key pair has to be used to decrypt it, right?
Yes, sir.
Yeah, that is what the secret key meant here. Okay, don't get confused that secret key means only this will have its secret key. It is public key. You can consider this as public key. Okay. Clear? Priyadarshan?
Yes, sir. Yes, sir.
Okay. So this diagram is very important, students, because if you have a question regarding writing the complete procedure, asked you to write the complete procedure of Kerberos authentication system, you have to write this diagram. If you write this diagram as it is more than sufficient. Okay. So let us stop here. I will share the slides to you by today. Uh, uh, I'll stop recording. Tomorrow we'll continue with other topics. Okay. So